ಬಟ್ಟೆ ಆಗೋಯ್ತು ನಂದು.
ಜಾಣಿ ಅಪ್ಪನ
ನಾಲ್ಕು ಓಕೆ. ಇನ್ನು ಅರ್ಧ ಗಂಟೆ ಆಗುತ್ತಲ್ಲ ನಿಂದು.
10:15.
ಮತ್ತೆ ಸ್ನಾನ ಮಾಡಿ ಪೂಜೆ ಮಾಡಿ.
Sahana, unmute yourself and tell me the screen is visible and audible.
Hello, sir.
Screen is visible and audible.
Yes, sir. It's visible.
Okay. Why only 10 students attended?
Join ಆಗ್ತಿದ್ದಾರೆ ಸರ್ ಈಗ.
ಹೌದಾ? ಯಾಕೆ ಇವ್ರು KOM ಕ್ಲಾಸ್ ಲೇಟ್ ಮಾಡಿದ್ರಾ?
ಹಲೋ.
KOM ಕ್ಲಾಸ್ ಎಕ್ಸ್ಟೆಂಡ್ ಮಾಡಿದ್ರಾ ಅಂತ ಕೇಳಿದೆ.
ಇಲ್ಲ ಸರ್.
ಇಲ್ಲ ಅಲ್ಲ? ಓಕೆ. Good morning, everybody. Last class, we discussed about introduction of solidification. The solidification is nothing but the change or transformation of liquid phase to solid phase. The meantime, the heat transfer between the liquid metal and the surrounding and the bottom and the surrounding and the walls of the mold cavity. Due to the heat transfer, the freezing takes place and the phase transformation takes place. Solid state, liquid state to solid state. That's the introduction of solidification. Usually in solidification, 3 words are very, very important. First one, nucleation, crystal growth, and grain boundary. Crystal nucleation means the nuclei formed in the liquid metal and grow in size, attract the neighbor nuclei, and forms the crystal. After that, crystal again grows in the just like an antenna of TV, The same way the crystal grows and forms the grain boundary. So these three words are very, very important: nucleation, crystal growth, and grain boundary. And all of you observe here, this is very, very important for mechanical engineers. So what you understand from the word the crystal growth? The crystal growth means the crystal grow in size and reaches the maximum critical size or maximum size and attract the neighbor nuclei and forms the crystal. And again, the crystal attract the neighbor crystal and forms the crystal structure. All of you studied in the material science, there will be three types of crystal structures are observed in metals, that is BCC, FCC, and HCP. Depending upon the placement of the atom in the crystal structure, which is classified into BCC, FCC, and HCP. All of you observe here, the crystal grow in size just like a antenna of the TV. And all of you observe here, this is the photograph taken from SEM, scanning electron microscope. Just see this, the 1 millimeter length, how the crystal grow in size. And this is the structure of the metal. This is for pure aluminum and this is for iron. And this is the diagram. Crystal grow in two directions, X and Y, and the slope which indicates the critical angle alpha. Next, this is the explanation for crystal growth, which is shown in the diagram 1, 2, 3. Next, come to the point, all of you write down nucleation. Nucleation, all of you
Hello.
write. Hello.
Sir, students waiting here.
Okay. Join Kelu Bega.
Join address, sir.
Okay. All of you write down nucleation. See, the nucleation means the nuclei form in the liquid metal. All of you observe here like this and grow in size and attract the neighbor nuclei and forms the crystal. For this, see, this is the diagram. This is the free energy, and x-axis the particle radius, the volume of the particle that is in the sphere shape. This is the volume of the particle and the area of the particle. And this diagram indicates the reversible and irreversible nucleation process. That is nothing but if you give the heat to the metal, that forms the liquid, and the heat extraction or heat transfer takes place from liquid metal to the bottom of the mold, and heat transfer between the walls of the mold wall and the heat transfer between the liquid metal and the surrounding. The process is reversible if you provide the heat. If you extract the heat, the process is irreversible. And this is the delta G is the critical size of the nuclei or is the radius of the nuclei. The shape of the nuclei is sphere shape. Pi d squared by 4. The shape of the nuclei is the sphere, and you have to see the area and the volume of the sphere-shaped nuclei or crystal. This is the critical size. That's the maximum size of the nuclei. All of you observe here. This is the nuclei. Attract the nuclei, neighbor nuclei, and forms the structure. And again, that grow in size, forms the grain boundary. The same type of another crystal near to that is attracted and forms the crystal structure. Step by step. Step 1, the nuclei form. Step 2, attract the neighbor nuclei and forms the crystal like this. Crystal grow in size, forms the grain boundary. After growing to the maximum size or critical size, attack the neighbor crystal and forms the crystal structure like this. This is the diagram for nucleation process. The nucleation can be divided into two, primary and secondary. And primary, there will be two types. One is homogeneous and other one is heterogeneous. In the secondary, that may be a different type of nucleation depending upon the type of metal and the type of process and the formation of crystal structure. First, to come to the point, all of you write down nucleation. Write this diagram, show the diagram and show the x-axis and show the curve like this and show the line, vertical line like this, and show this. This is the critical size of the nuclei, or radius of the nuclei is R. This is the delta G. That's the free energy required to form the crystals. And first step, the metal is in liquid condition. Nuclei forms and attract the neighbor nuclei and grow in size and forms the grain boundary. All of you observe here, this is the grain boundary, and this is the attract the same type of crystal, neighbor crystal, and forms the crystal structure. The nucleation process completed in 5 steps. The metal is in liquid condition, that you can call it as monomer. The nuclei forms in the sites or in the locations where the heat transfer takes place. Heat transfer between the bottom of the mold from the liquid, and heat transfer between the liquid metal and the wall of the mold, and the heat transfer between the surface of the liquid metal and the surroundings of the mold. Then attract the neighbor nuclei and forms the crystal, and crystal grow in size, forms the grain boundary. Again, the same type of another crystal formed near to that neighbor, which is attracted by the previous nuclei crystal and forms the crystal structure. This is the steps required for nucleation process. 1, 2, 3, 4, 5. And nucleation is divided into two: primary nucleation, secondary nucleation. Primary nucleation again is classified into homogeneous and heterogeneous. Please, all of you write down the flow diagram, block diagram. Write down first nucleation, and secondary nucleation will not be observed in metals because it's the process of special type of nucleation. When you mix with the metal with the non-metal or some other metal, the secondary type of nucleation takes place. As per your syllabus, you have only primary. Primary is classified into homogeneous and heterogeneous. Write down the block diagram. First, you write down nucleation, divide this into two, and right side you show this in dotted line, secondary nucleation. The primary nucleation is divided into two: homogeneous nucleation, heterogeneous nucleation. Oval with circle, here only circle. And here you show the square. Mark it very, very important. Almost all the question paper, you have a question on nucleation in module 3. That's in question number 5. See, this is a very important. You can expect this question in the examination. See, all of you observe here, the nucleation is classified into two, primary nucleation and secondary nucleation. Usually, in all the practical solidification process, we observe only homogeneous and heterogeneous. The secondary type of nucleation will not be observed because of the nucleation takes place with the non-metal and the metal or some PVC material, or the crystal structure are different from each one, different from other metal, or if you mix metal with non-metal, metal with wood, metal with other metal, the secondary type of nucleation takes place. It's not much important for you. You have only primary nucleation that's classified into two, homogeneous nucleation, heterogeneous nucleation.
Excuse me, sir.
Okay, tell me.
Sir, Zishan wait ಮಾಡ್ತೀವಂತೆ ಸರ್ ಇನ್ ಮಾಡ್ಬೇಕಂತ
ಜಾಯ್ನ್ ಆಗಕ್ಕೆ ಹೇಳು.
ಹೇಳಿದ್ದೀನಿ ಸರ್ ಅವನಿಗೆ
ಯಾರು ಇಲ್ಲಲ್ಲ, ಇಲ್ಲಿ ಯಾರ್ದು ತೋರಿಸ್ತಾ ಇಲ್ಲ.
3-4 ಜನ ಮೆಸೇಜ್ ಮಾಡ್ತಾರೆ ಸರ್ ಇನ್ ಮಾಡಕ್ಕೆ.
ಟ್ರೈ ಮಾಡಕ್ಕೆ ಹೇಳು, ಜಾಯ್ನ್ ಆಗಿ ಟ್ರೈ ಮಾಡಕ್ಕೆ ಹೇಳು. ಜಾಯ್ನ್ ಆದ್ರು. Shall I start?
Okay, sir.
All of you write down nucleation. Write down a sentence. Nucleation is the beginning of phase transformation. Nucleation is the beginning of a phase transformation. Full stop. You continuously write the explanation. Nucleation is marked by first sentence. Nucleation is the beginning of the phase transformation. In bracket, write down liquid phase to solid phase. Close the bracket. Nucleation is marked by the appearance in the molten metal of tiny regions called nuclei, which grow in size to form solid crystals by, don't put the bracket, solid crystals to form solid crystals by further deposition of atoms. Full stop. Next paragraph, write down. Nucleation may involve the assembly of proper kinds of atoms by diffusion assembly of proper kinds of atoms by diffusion. Full stop. The structural change into one or more unstable intermediate structure. Unstable intermediate structure. What do you understand from the sentence? The structural change into one or more unstable intermediate structure. See, you have already studied the phase diagram of cast iron. Last semester, you have studied the material science and metallurgy. In metallurgy, you have studied the behavior of metal, the cast iron, at a different temperature. At 900 degrees centigrade, the cast iron has FCC structure. When it comes to the temperature of 1350 degrees centigrade, the FCC changes into BCC crystal structure. That is the structural change with respect to temperature, that is unstable intermediate structures. The change in the structure FCC to BCC with respect to the temperature, that is due to the formation of crystal structure. Formation of crystal structure. At 900 degrees centigrade, you have FCC, which changes into BCC at 1350 degrees centigrade. That is due to the temperature change and the structural change. Next, write down the formation of critical sized particle, that is nuclei of the new solid phase. New solid phase. The formation of critical sized particle, that is nuclei of the new solid phase. So as I told you last class, what is the age of human being? What is the growing age of a human being? The growing age of human being is 19 years. So after 19 years, the growth ceases. That is the maximum height human being reaches at that age, 19 years. After that, there is no growth takes place. In the same way, the maximum size of the nuclei reaches and attracts the neighbor nuclei and forms the crystal. For that good example, say this is the nuclei formed and attracts the neighbor nuclei and forms the nucleation of a bigger size of nuclei or crystal. And this is the crystal growth. This is the crystal growth and reaches the maximum size or critical size. It is called critical size or maximum size. In the first diagram, all of you observe here, this is just like an antenna structure. Nuclei appears, grow in size and attract the neighbor nuclei and grow in size and forms the critical sized particle or crystal, and the same way which attract the neighbor nuclei with the crystal already grown and forms the structure, and this is the grain boundary of the crystal, From this only you can identify whether the metal has BCC structure or FCC structure. Next, write down fundamentals of nucleation. Fundamentals of nucleation. All of you underline this. Fundamentals of nucleation. Always write the title in uppercase letters. Underline that. In your lifetime, remember, always write the title in uppercase letter. Underline that. Wherever you write the report or the any message or any notes, write the title in uppercase letter. Automatically that indicates that is title of the explanation. Write down fundamentals of nucleation. The nucleation, say all of you observe here, the nuclei grow in size, attract the neighbor nuclei nucleation forms that grow in size reaches the maximum. That is the fundamentals of nucleation. Say, the nucleation is classified, broadly classified into two. First, you write down fundamentals of nucleation, underline that. Below that, write down the nucleation is classified into
Excuse me, sir.
two. Yes, tell me.
ದಾನಿಶ್ ವೇಟ್ ಮಾಡ್ತಾರಂತ ಸರ್. ದಾನಿಶ್ ವೇಟ್ ಮಾಡ್ತಾರಂತ ಸರ್.
ನೋಡ್ತೀನಮ್ಮ, ಟ್ರೈ ಮಾಡ್ತೀನಿ. ನೋಡು, ಜಾಯ್ನ್ ಆಗಕ್ಕೆ ಹೇಳು. ಹಲೋ,
ಹಾ ಸರ್, ಹೇಳಿದ್ದೀನಿ.
ಹಾ, ಜಾಯ್ನ್ ಆದ್ರ?
ಆಗಿಲ್ಲ.
ಯಾರೋ ಒಬ್ರಾದ್ರು.
ಸರ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಮ್ಯಾಥ್ಸ್ ಕ್ಲಾಸ್ ಇದೆ ಅಂತ ಹಾಕಿದಾರಲ್ಲ, ಅದಕ್ಕೆ ಹುಡುಗರು ಕನ್ಫ್ಯೂಸ್ ಆಗ್ಬಿಟ್ಟಿದ್ದಾರೆ ಸರ್.
ಅದೇಂಗ ನನ್ನ ಟೈಮಲ್ಲಿ ಮ್ಯಾಥ್ಸ್ ಕ್ಲಾಸ್ ತಗೊಂತಾರ ಅವರು?
ಹಳೆ ಲಿಂಕ್ ನೇ ಶೇರ್ ಮಾಡಿದ್ದಾರೆ ಸರ್.
ಎಲ್ಲರಿಗೂ ಹೇಳ್ಬಿಡಮ್ಮ, ನನ್ನ ಕ್ಲಾಸ್ ಯಾವತ್ತೂ ಚೇಂಜ್ ಆಗಲ್ಲ, ಇದು ಕಂಟಿನ್ಯೂಸ್ ಅಂತ. ನಾನು ಹಾಗೆ ಚೇಂಜ್
ಅಂತಾನೆ ಇದೆ ಟೈಮ್ ಅದಕ್ಕೆ.
ಅಲ್ಲಮ್ಮ, ಚೇಂಜ್ ಆಗೋದಾದ್ರೆ ನಾನು ಪ್ರತೀಕಿಗೆ ಮತ್ತೆ ನಿಮ್ ಗ್ರೂಪ್ ಅಲ್ಲಿ ಕ್ಲಿಯರ್ ಆಗಿ ಇನ್ಫಾರ್ಮೇಶನ್ ಕಳಿಸ್ತೇನೆ. ವಿತೌಟ್ ಕಮ್ಯುನಿಕೇಶನ್ ನಾನು ಯಾವತ್ತೂ ಕ್ಲಾಸ್ ಚೇಂಜ್ ಮಾಡ್ಕೊಡಲ್ಲ. ನಾನು ಯಾವತ್ತೂ ಕ್ಲಾಸ್ ಚೇಂಜ್ ಮಾಡಲ್ಲ. ನನ್ನ ಕ್ಲಾಸ್ ಎಷ್ಟೊತ್ತಿಗಿದೆ? ಮಂಡೇ 8:20, ಟ್ಯೂಸ್ಡೇ 9:20, ಸಾಟರ್ಡೆ 10:45. ಇದು ಯಾವತ್ತೂ ಚೇಂಜ್ ಆಗಲ್ಲ. ನೀವೆಲ್ಲ ಕನ್ಫರ್ಮ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡಿ. ನೆಟ್ವರ್ಕ್ ಪ್ರಾಬ್ಲಮ್ ಇದ್ದೇನೋ ಪ್ರಾಬ್ಲಮ್ ಆದ್ರೆ ಆಗ್ಬೇಕಷ್ಟೇ ಹೊರತು ನಾನಂತೂ ಕ್ಲಾಸ್ ಯಾರಿಗೂ ಬಿಟ್ಕೊಡಲ್ಲ. ಅವರು ಈಗ ಕ್ಲಾಸ್ ಈ ಟೈಮಲ್ಲಿ ಕೇಳೋರು ಸಾಯಂಕಾಲ 5 ಗಂಟೆ ಮೇಲೆ ಇಟ್ಕೋಬಹುದಲ್ವಾ? ಹೌದು ಅಲ್ವಾ ಹೇಳಿ? ಈಗ ಇದೇ ಟೈಮಲ್ಲಿ ತಗೋಬೇಕಂತ ರೂಲ್ಸ್ ಇದೆಯಾ? ಸಾಯಂಕಾಲ 5 ಗಂಟೆ ಮೇಲೆ ತಗೊಂಡ್ಲಿ.
ಸರ್ ಅದು ಓಲ್ಡ್ ಲಿಂಕ್ ಅವ್ರದ್ದು ಶೇರ್ ಮಾಡ್ಬಿಟ್ಟಿದ್ದಾರೆ. ಅವರು ಓಲ್ಡ್ ಲಿಂಕ್ ಶೇರ್ ಮಾಡಿದಾರಲ್ಲ, ಅದ್ನಲ್ಲಿ ಆ ಟೈಮಿಂಗ್ಸ್ ಇದೆ ಅದ್ರಲ್ಲಿ.
ಸರಿ ಸರಿ ಸರಿ, ಓಕೆ, ಟೈಮ್ ವೇಸ್ಟ್ ಮಾಡಬೇಡಿ. ಡ್ಯಾನಿಶ್ ಬಟ್ ಜಾಯ್ನ್ ಆದ. ಓಕೆ, ಸ್ಟಾರ್ಟ್ ಮಾಡ್ಲಾ?
ಸರ್
all of you write down the title, fundamentals of nucleation. The nucleation is classified into, broadly classified into two. Please write down. The nucleation is broadly classified into two. Write down one by one. Number one, homogeneous nucleation. Next line, write down. Number two, heterogeneous nucleation. Homogeneous nucleation, heterogeneous nucleation. All of you listen here. This is very, very important for mechanical engineers. Homogeneous nucleation means solidification of pure metal. Remember, in your lifetime, homogeneous nucleation means solidification of pure metal. Only iron, only copper, only aluminum, or only magnesium. There is no alloying element. Pure 100% of pure metal. That is called homogeneous nucleation. Remember, in your lifetime, pure metal, 100% of gold, 100% of silver, 100% of copper, 100% of aluminum, 100% of iron. Without any alloying element, 100% pure metal, the solidification of pure metal is called homogeneous nucleation. Homogeneous nucleation means only one type of crystal structure observed starting to the end of the solidification process, whether it may be BCC or FCC. Homogeneous means pure metal, solidification of pure metal, whether it may be copper, aluminum, gold, silver, iron. Remember 5 metals: iron, gold, silver, copper, magnesium. Pure metal, solidification of pure metal. The only one type of crystal structure is observed starting from the solidification to the end of the crystal structure, end of the solidification process. The name itself indicates homogeneous. Only one type of metal, pure metal. Remember, in your lifetime, if you go to the any interview with the foundry, there they ask you the question, what is nucleation and the types of nucleation. Nucleation is divided into two: homogeneous nucleation and heterogeneous nucleation. The solidification of pure metal is called homogeneous nucleation. Homogeneous nucleation means pure metal, the same type of crystal structure. BCC, FCC or HCP crystal structure is seen in the liquid metal, in the solid metal throughout the stress transformation from liquid to solid. That's called homogeneous nucleation. And heterogeneous nucleation is nothing but the solidification of alloy. Solidification of alloy. Very good example: cast iron and aluminum alloy, copper alloy. Remember, heterogeneous nucleation means the solidification process of an alloy. That is solidification of alloy. That is called heterogeneous nucleation process. The homogeneous nucleation means the solidification of a pure metal. Pure metal. Remember, homogeneous, the only one metal, the only one type of crystal structure is observed from starting to the end of the solidification process in the liquid metal, in the solid metal. That is called homogeneous nucleation. The heterogeneous nucleation means the solidification process of alloy, solidification process of an alloy. For example, cast iron, aluminum alloy, copper alloy, aluminum alloy, copper alloy, duralum for aluminum alloy, copper alloy, brass, cast iron, brass, duralumin. So these three are very good example for heterogeneous nucleation. And the homogeneous nucleation, pure metal of gold, silver, iron, magnesium, like that, pure metal, 100% pure metal. The solidification of pure metal is called the homogeneous nucleation. Heterogeneous nucleation means the solidification of a alloy, solidification of an alloy. For this good example, cast iron, duralumin and brass, aluminum alloy, copper alloy and iron alloy. For iron alloy, good example, cast iron, iron with copper, so iron with carbon, and aluminum alloy, aluminum with silica, and copper alloy with copper with zinc, lead and tin. That is, in that metal, in that alloy, we observe the heterogeneous nucleation. We observe homogeneous nucleation in pure metal. Pure metal. Remember, in your left hand, homogeneous nucleation means the solidification observed in pure metal is called homogeneous nucleation, and the heterogeneous nucleation means the solidification process observed in the alloy. Good examples: cast iron, duralumin and brass. Cast iron, it is the combination of iron and carbon. Duralumin, aluminum with silica, and brass, copper, lead, tin and zinc. The nucleation process observed in alloy is called heterogeneous. The nucleation process is observed in pure metal is called homogeneous nucleation. For this good example, homogeneous, all of you observe here, the homogeneous mixture of the same type of mixture, the same type of liquid. And this is the brass, this is the mixture of copper, tin, zinc and lead, and the coffee decoction of coffee powder, water, and sugar,
Hello.
and the air.
Hello.
ಹೇಳಿ.
ಬ್ರಾಸ್ ಇಸ್ ಏನ್ ಹೆಟ್ರೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್ ಇರುತ್ತಲ್ಲ ಸರ್ ಅದು?
ಹೌದು. ಇಲ್ಲಿ ಸುಮ್ಮನೆ ಎಕ್ಸಾಂಪಲ್ ತೋರಿಸಿದ್ದಾರೆ ಅಷ್ಟೇ, ಇಲ್ಲಿ ಬೇಡ ಅದು ಬರ್ಕೊಬಿಡಿ. Next you see this diagram. Mixture of salt and water. Heterogeneous. Sugar and water. Copper sulfate and water. Mixture of sand and water. Mixture of mud and water. You can think like this. The alloy that is called the solidification process observed in alloy is called heterogeneous nucleation. The solidification process used in solidification process observed in alloy is called heterogeneous nucleation. Now all of you write down homogeneous nucleation. And all of you write down this diagram. This is the volume of the sphere of the nucleus, and this is the area, 4 pi r squared gamma. Here it is 4 by 3 pi r cube delta Gf, free energy. This is the R critical, delta G nuclei, and this is delta G surface, SURF. The free energy, excess free energy, delta G. Now write down homogeneous nucleation. Say, all of you observe here. Homogeneous nucleation, when a pure metal cools down in the liquid state, it will transform to the solid state at some temperature. Say, the free energies of liquid and solid are same. Free energy means the energy required to transform from liquid state to solid state. That is due to the heat transfer between the bottom of the mold, heat transfer between the walls of the mold, heat transfer between the liquid metal and the surrounding, that is surface, that is pi r square gamma, the volume of the nuclei, that is delta G volume equal to 4 by 3 pi r cube delta G F. Radius of nucleus is R. Delta is the critical size of the nuclei, that is R critical. All of you write down. When a pure metal cools down in the liquid state, comma, it will transform to the solid state at some temperature. Don't write this from thermodynamics 17. There is only one temperature at which a pure solid metal can coexist with pure liquid metal. Say, if the decrease in free energy decrease in free energy that promotes the solidification process. All of you observe your excess free energy delta G. The free energy means the energy required to transform the liquid metal to solid metal, that is liquid state to solid state. Heterogeneous nucleation, underline that, write down the solidification process observed in alloys that is the nucleation is heterogeneous and occurs on solid surfaces in the liquid foreign substances such as alloying elements carbon in cast iron comma silica in aluminum alloy duralumin DURALUMIN silica in duralumin in bracket write down aluminum alloy and lead, zinc and tin in brass, copper alloy, full stop. The foreign substances may be insoluble impurities or some other material. All of you observe your, see, The heterogeneous nucleation is nothing but the solidification process observed in alloy. Observed in alloy. That is the solidification is nothing but nucleation of different types of substances present in the alloy. For example, in cast iron, you have iron and carbon. The nucleation of carbon and iron is a different one. The solidification process observed in the alloy, that is called heterogeneous nucleation. And homogeneous nucleation means the pure metal. The solidification process observed in pure metal. Pure metal. You just write this diagram in the examination and write the homogeneous nucleation and heterogeneous nucleation. Just write down the question. What is nucleation? What is nucleation? Put a question mark. Explain briefly. Explain briefly the types of nucleation process. Types of nucleation process. Nucleation, first to define the nucleation, that is nothing but the solidification process, and the types of nucleation: homogeneous nucleation and heterogeneous nucleation. Homogeneous, the solidification process is observed in pure metal. Example: iron, gold, silver, zinc, copper, aluminum. And heterogeneous nucleation, good example: cast iron, aluminum alloy, and copper alloy. Aluminum alloy means duralumin, and copper alloy means bronze. And for explanation, write this explanation: homogeneous nucleation, and write this diagram. And heterogeneous nucleation, only you write the explanation. For this, no write the diagram. Now I stop at this stage. I will continue in the next class. Now all of you write your name and USN in the chat box. Answer roll call. All of you unmute yourself and answer roll call. Pawan HR.
Present, sir.
Hemant KS. Prathamesh.
Present, sir. Present, sir.
Prema H. Sushant.
Yes, sir. Present, sir.
Sahana V.
Present, sir.
Hemant.
Present, sir.
Nishchit Gowda.
Present, sir.
Manoj YB.
Yes, sir.
Mithun Naik. Akshay M. Patil.
Yes, sir.
Harshavardhan.
Present, sir.
Vignesh. Kumaraswamy. Nikhil Gowda. Atal B.
Yes, sir.
Bhagat HR.
Yes, sir.
Chhatrapati Chetu.
Yes, sir.
Pratik S.
Yes, sir.
Vignesh. Nutan.
So
Nazma.
Vignesh is present.
Yes, sir.
Okay. Nazma.
Yes, sir.
Darshan.
Yes, sir. Present, sir.
Okay. Chandan RC.
Yes, sir. Present,
Jayant L. Adil SU.
Present, sir.
Aditya.
Yes, sir.
Shashank Bilagi. Harsha MR.
Present, sir.
Ganesh Naik. Manoj H. Krutik.
Sir.
Kumaraswamy. Chetan AB.
Present, sir.
Jishan.
Yes, sir.
Vivekanand.
Present, sir.
Ashwin.
Yes, sir.
Mohan Raj, Karthik MK,
Yes, sir.
Anush.
Sir, Naya Sharif.
Okay. Nash Sharif ಇನ್ನು ಬಂದಿಲ್ಲ ತಡಿ. ಭೈರಪ್ಪ ಹೆಗಡೆ.
Sir, Malhar present, sir.
Naya Sharif. Okay. ಭೈರಪ್ಪ ಹೆಗಡೆ.
Yes, sir.
Abhilash. Sharath.
Yes, sir.
Dhanush.
Yes, sir.
Jnanesh.
Yes, sir.
Shahid.
Yes, sir.
Danish Bhatt.
Present, sir.
Mohammad Raja.
Yes, sir.
Yes, sir.
Lohit Kumar.
Yes, sir.
Vignesh.
Present, sir.
Rasool.
Present, sir.
Sharath Madik.
Present, sir.
Okay. Anybody else?
Sir, Prema.
Sir, Aditya.
Prema present. Okay. Next.
Malhar Vivekanand.
Sir, Mohan Raj.
Mohan Raj. Okay. Next.
Sir, Aditya.
Aditya J. Okay. Next.
Sir, Malhar.
Huh?
Malhar Vivekanand.
Vivekanand present amma. Okay.
Sir, Nutan.
Nutan. Okay.
Anush.
Anush. Okay.
Sir, Abhilash.
Abhilash. Okay.
Sir, Shashank.
Shashank. Okay. Now I stop at this stage. I will continue in the next class.